Hi, everyone. We're going to talk now about the difference between a one-tailed analysis and a two-tailed analysis. In our six red cards magic trick, that was a one-tailed analysis because we saw six red cards and we asked, so what was the probability of getting six red cards among the first six cards just by chance with a random deck? But then someone might argue, but now wait a minute. If you want a measure as to how unusual that is, shouldn't we be fair? Shouldn't we also use symmetry? You can make the argument that we should consider not just the probability of getting six red cards in the first six cards, but also the probability of getting six black cards in the first six cards. That would be a two-tailed analysis. And it really depends on the structure of a test. You are going to see both one-tailed and two-tailed hypothesis tests. And there are related one-tailed and two-tailed p-values, especially when there's symmetry involved. So in example 2, we're going to revisit the six red cards example, but we're going to calculate the p-value differently. We're going to use a two-tailed analysis to get a two-tailed p-value. In example 1, the earlier magic trick, we calculated a one-tailed p-value because we focused on the probability of the top six cards being all red. I'll put that in red. Actually, this should be in another color. Let's say blue. Well, okay, so I'll put red around one-tailed, right? In part B, we did a one-tailed analysis. Now, in example 2, we're going to do a two-tailed analysis, okay, where we consider the following. One could argue that it is more appropriate to calculate the probability of the top six cards being all the same color, whether they're all red or all black. And we're using ideas of symmetry. And this would be a two-tailed p-value. So here, we're looking at the probability that the top six cards are the same color, given that the deck of cards was truly random. That's still our same null hypothesis. Well, we take the probability that the first six cards out of six are red, given the null. That was 0.0113, 1.13%, roughly. Okay, and we add to that the probability that the first six cards are black. Because of the symmetry between the red cards and the black cards, it's the same probability. It's 0.0113. So the total p-value, the total two-tailed p-value, and this is often the case when we calculate two-tailed p-values, we take twice the one-tailed p-value, we take twice 0.0113 by symmetry, and we get 0.0226, or 2.26%. So we have a different measure here. Is it too low? Is it so low that the null must go away? Well, it depends on alpha. If alpha is 5%, then we reject the null in both the one-tailed and two-tailed cases. Okay, so here's another way of calculating a p-value by using a two-tailed p-value. Wait, what's this idea of tails? I mean, we're talking about six red cards, six black cards. What's this idea of tails? Why tails? And we'll do that in the next video. Why tails?